This would be a Newman motor. It is also an absolute mess, just in case there was any confusion here. Now, quick update. Currently, this is switched by a H-bridge, all electronic switching, with only 2 magnets on the wheel, triggering a decade count at 4017. So, boring bits out of the way. This shaft is so piddly looking, but if I try to hold it still at its most powerful point, I'm about to do that now, grasp on and squeeze, grasp on and squeeze, I can't stop that shaft. I cannot stop it. It's a very expensive motor. It's about over $100 worth of magnets, $100 worth of wire, and some other cheap and nasty stuff that I had lying around in the fridge, or the shed. Obviously, that's not where I keep my old newspapers. But it's so powerful and turned down so low, the input power to that is 40 volts and an average of approximately 5 milliamps. Now, that equals about 0.2 of a watt. So although it's not spinning very fast, it does have quite a lot of torque. In fact, an awful lot of torque. So, this is why I picked up the camera for the first time in a week. It is no longer running on relays, which weren't quick enough and they were causing a lot of problems. It's not running on commutators, because I haven't tried them yet. That's more of a last resort. We've got Hall effect sensors instead of reed relays, and there are no latching circuits. The reason why I say all that is because switching is the difficult part of this motor. Very difficult. It's going to take a really high voltage to get any power out of it. That's 40 volts. I'm looking at going up to as high as I can, really, preferably at least 1,000 or so, but I'm probably not going to be able to do that with these transistors. Relays are going to be problematic because they'll spark and they'll weld up, and relays are not very good for high voltages unless you custom make them. Transistors would be perfect for a motor, but the biggest, highest voltage transistor I can get is custom made by a company called XMS, 2,500 volts, and they cost about $40 a piece. So that's not really a practical proposition, since I require 4 of them and they're a bit delicate. But these ones here, they cost about $1.50 each, and they're good for 1,500 volts instead of 2,500. So that is an excellent way to go. So I've got all the electronics down to a value of less than $10, and a really high torque output with a really high small power input. There's the scope shot, positive and negative, straight across the motor, both channels. Blue is one side of the motor, yellow is the other side of the motor. Bit of an overlap in the middle, but the transition point is very tight. There's definitely some room for improvement there. As you can see, if I get right in close, which is a bit difficult to do, the scope is extremely antiquated as far as digital scopes go. Just a whisker more and we'll be able to see that transition point clearly. Interesting. So yeah, definitely some overlap. Otherwise, no small room for improvement. I could do that and solve another problem at the same time by turning this magnet off when it reaches the top. That top bit of the transition in the arc is causing some difficulties. It would be best to just put a flywheel on and get rid of that. But the magnets on the timing wheel were set up to do that, but they've caused some problems in the past with the relays. That'll be one thing. I'll set up the duty cycle to get working again as I want. Turn up the voltage. I make this video because I anticipate now that it's working, I'll probably going to blow it up in about 5 minutes time after I've hooked up a basic oscillator into this microwave oven transformer, and I'm about to pump the voltage up incrementally. 40 volts is obviously enough to be very interesting, but more interesting still would be several hundred or even thousand. This microwave oven transformer has been very conveniently modded. I've just cut the primary right down the middle, so the primary is in 2 parts, and using just a bistable vibrator with the positive from my power supply going into the center tap of this transformer, and either end of that primary winding goes out to the collector of a transistor. So obviously you just got to switch the transistors on one by one and ground them, and that will be easy simply by hooking a resistor to the base, in this case 1K, to the base of each transistor, and to the other side to the collector of the opposing transistor. So yeah, that's done to both the bases, and then you turn it on and it just automatically starts oscillating. It's really very simple. So have another play, get some more power into it, and check back tomorrow. But that's worthy of note. I think so. Worthy of note. Survey the magnificence. See you again tomorrow.